Hello students, in the last video I showed you how to solve various kinds of problems based on chemical equations and mole concept. Now I have some more problems which are a little more difficult than that. So in this video we are going to focus on some more difficult problems. Okay. So here we have a question based on chemical equation. So it is NaCl plus AgNO3 gives NaNO3 plus AgCl. The question says when excess of silver nitrate solution was added to a solution of sodium chloride, 14.35 grams of silver chloride were precipitated. What mass of sodium chloride was present in the original solution? So the question here says excess of silver nitrate was added to a solution of sodium chloride. Silver chloride, the weight is 14.35 grams of silver chloride is precipitated. Now they are asking what mass of sodium chloride was present in the solution. Okay. So how to find out this? They are giving the weight of silver chloride, the weight of AgCl, and they are asking the weight of NaCl, how much sodium chloride was present. So it is backwards. Okay. So let us first calculate number of moles. This is 1 mole and this also is 1 mole. Okay. So let us take the molecular mass of sodium chloride. Atomic weights are given here. Na is 23, Cl is 35.5. So it will be 58.5 grams on adding these two. Now AgCl, Ag, silver is 108, chlorine is 35.5. So it is 143.5 grams. Okay. So these are the masses. Now they are saying silver chloride precipitated is 14.35 grams. This is given. So this is to be found. How much sodium chloride was X? I think you got this is the ratio. Okay, understanding the question is the most important part. If you understood, now we can find out. So from this we can write 58.5 upon X is equal to 143.5 upon 14.35. Okay. Now what is X? X is equal to, X goes to the other side. This will remain 58.5 into, we have 14.35 divided by 143.5. It's very simple. Divided by 10. Now 58.5 upon 10 is equal to 5.85 grams. Okay. The question, understanding is very important. Once you understand, then you will be able to solve. Let's have the next question. Here we have 29.25 grams of sodium chloride reacts with excess of silver nitrate. And calculate the mass of silver chloride precipitated in this reaction. Also find the mass of silver nitrate. So silver chloride is precipitated is asked. Also find the mass of silver nitrate reacted. This mass is asked. What is given? Sodium chloride, the weight of sodium chloride is given. So this can be ignored. Only these three things we require. Let us find the moles. 1 mole and this is also 1 mole. This also is 1 mole. Okay. Now sodium chloride, what is the molecular mass? Using the atomic weights given here, it is 58.5 and this AgNO3. Silver is 108, nitrogen is 14, oxygen 3 into 16, 48. So on adding, $170 grams, and NaNO3 is not required. Silver chloride, that is 108 plus 35.5. So 143.5 grams. This also is there. Now the weight of sodium chloride given in the question is 29.25. This is there. This will be X and this will be Y. Okay. So these are the ratio. 58.5 upon 29.25 is equal to 170 upon X, that is equal to 143.5 upon Y. This ratio we have. Now mass of silver chloride, first part of the question. Mass of AgCl. How do you find? Let us take this. This is the fundamental value given. We will take it 58.5 upon 29.25. is equal to, we want AgCl, so we will take this ratio, that is 143.5 upon Y. Okay, so what is Y here? Y is equal to, Y comes this side, so 143.5 into 29.25 upon 58.25. Okay, so this is just half of this, so it is 2. So this will be divided by 2, that is equal to, so 143.5, that is 71.75. Okay, you can divide it. Then next part of the question is mass of silver nitrate. Mass of AgNO3. Here the ratio, first part will be the same, 58.5 upon 29.25 is equal to, this will be taken 170 upon X. So from here what is X? X is equal to 170 into 29.25 upon 58.5. Yes, so this will cancel 2, so this will be cancel 85. It's equal to 85 grams. Okay, I think you got it. So you can see solve this question again and check if you get the same answer. And now we have a third question here. A mixture of 22.4 liters of nitric oxide and 22.4 liters of oxygen are ignited. Calculate the volume of nitrogen dioxide produced. Also find the volume of unreacted gas, if any. So applying the mole concept or Gay-Lussac's law can be directly applied because all are gases. 2 moles, 1 mole and 2 moles. Okay, mixture of 22.4 liters. This is 22.4 liters and 22.4 liters of oxygen also is taken, 22.4 liters. So calculate the volume of nitrogen dioxide produced, this is to be found. So we can apply now, this can be taken as X. How do you find? If this is 22, 2 moles, 2 volumes, applying Gay-Lussac's law directly instead of going to mole. So 2 moles or 2 volumes we can say. This is 2 volumes. So if this is 22.4, this also is 22.4. Okay. So we have the volume of nitrogen dioxide. Now find the volume of unreacted gas, if any. What is unreacted gas? 22.4 liters of nitric oxide is reacting, 22.4 liters of nitrogen dioxide is coming. So these are complete. Now nitric oxide is completely. Now how much oxygen will be used? 2 moles of nitric oxide requires 1 mole oxygen, means half of this will be used. So how much oxygen is used in the reaction? So for that we have to find out 2 upon 22.4, 1 upon X. Let us take this one as X and then find out how much oxygen is used. Okay, I can solve it here. So 2 upon 22.4 is equal to 1 upon X. So okay, so what is X? X is equal to 22.4 upon 2 is equal to 11.2 liters. So the volume of oxygen used is 11 but we have 22.4 liters. In the reaction we have taken 22.4 but only 11.2 gets used. So what is the unreacted gas? Unreacted gas is 22.4 taken minus 11.2 used is equal to 11.2 liters of oxygen. I don't know you are following or not. See what is happening here. If you see the Gay-Lussac's law, 2 volumes of nitric oxide, 2 volumes of nitrogen dioxide is formed. Oxygen is 1 volume, but we have taken 22.4. We need only 11.2, but we have taken 22.4. So that is why it is excess. In other words, if you start calculating 1 volume is 22.4, then this will be double. But then you need more of nitric oxide, which is not there. So you have to go by the least one available. So this will be in excess. Only 22.4 liters of nitric oxide is available. If you want to react 22.4 liters of oxygen, then you need double of this, which is not available. So this half of this will be used. This will be useful. Half of this will be used. So that is how you go by that. So you know there will be unreacted oxygen. Oxygen is in excess. The next question. Calcium carbonate on heating decomposes here. Okay, now in a given experiment results in 5600 ml of carbon dioxide being produced. What weight of calcium carbonate was heated and what weight of calcium oxide was formed at the same time? Okay, so let us see this question. CaCO3 gives CaO plus CO2. 1 mole, 1 mole and 1 mole. Okay, now atomic weights will be given. You should remember the calcium is 40, carbon is 12 and oxygen is 16. This will be given in the question, don't worry. So here calculate the molecular mass. 1 mole means 1 into calcium is 40, carbon is 12, oxygen 3 into 16, 48. So adding you get 100. So 1 into 100. Here you have calcium 40 plus oxygen 16, 56. Okay, grams. This is grams. Now here 1 mole of carbon dioxide is a gas, 1 into 22.4 liters. So these are the ratios we have. Now in a given experiment, 5600 ml of carbon dioxide is produced. 5600 ml means converting into liters, it will be, because we are taking this one as liter. Either you convert this or you convert this. This can be converted into molar volume or this will be converted into 5.6 liters. Okay, both should be in liters, same unit. Or convert molar volume into milliliters, 22,400. So then the ratio can work. Okay. Now what is asked? What weight of calcium carbonate? This one is X. And what weight of calcium oxide? This is Y. This one is 5.6 liters. Okay. So we have the primary ratio here, 22.4 upon 5.6 of CO2. So let us find out X, that is mass of CaCO3. How do you find out? 100 upon X is equal to 22.4 upon 5.6. So what is X? X is equal to 100 into 5.6 upon 22.4. We know this is 4 times. Okay, 4 and this 25 is equal to 25 grams. Okay, so this is mass of CaCO3. Second part is the mass of calcium oxide. So let us calculate mass of calcium oxide. How do you get mass of calcium oxide? Let us take this ratio from here. The ratio, the primary ratio 22.4 upon 5.6 will remain. 22.4 upon 5.6 is equal to calcium oxide. The ratio is 56 upon Y. Okay. So it is 56 upon Y. Now what is Y? Y is equal to 56 into 5.6 upon 22.4. Okay, cancel this. This will be 4, and this also can be cancelled. 2 and 28, and 2 and 14. Okay, so it is equal to 14 grams. Answer is 14 grams. Okay, so I hope you understood this. Please keep solving these questions, and we can watch the video again and again if you don't understand. And if you need more questions or any doubt, you can write in the comment section. Thank you for watching. God bless you.